Hello. So, our first video for today is going to be about general advice for some of the questions that you're going to experience on the homework that you have probably in front of you right now. Hopefully you've been able to work your way through a couple of the problems already, and if not, or if you've been running into some issues or having some questions, maybe some of the thoughts in this video will help you out. We're going to be talking about 4 different question types. Question 1, 4, 5, and 6, and question 7. We'll be working through some examples or just talking about some general advice. If you want to skip ahead to any of those videos, I'll try to make a point or point out which question we're talking about as we go along. Go ahead and skip ahead if you want to at this point. But I'm going to start with just kind of setting up the first question. Question 1, which is 3/2 x plus 2/5 y equals 5, and then 3x minus 2y equals -4. This is the same exact question that you had, the first question there. Now we're not going to solve this all the way through, I just want to give you a piece of advice. Obviously there's fractions here. A few of the problems on your homework will have fractions or decimals. And if you remember back from the beginning of the second chapter, where we were working with equations with fractions, the general suggestion is to try to multiply your equations by something that will get rid of those fractions. Try to multiply by something that will make the fractions go away, so that you don't have to deal with them anymore. Obviously, in the second equation, we don't have any fractions, so there's not really anything to worry about there. But in the top equation, we do. And so, as you've noted in class, when you multiply an equation by something, and if you remember from previous times, we have to multiply each part of the equation by the same constant, or really anything, the same thing, in order to make those fractions go away. So we look at the denominators, the 2 and the 5 there, and we think about what denominator, what number could I multiply both of those fractions by to make both of those denominators go away. In this case, it's 10, because if I multiply this term by 10, that'll evenly divide, and if I multiply this fraction by 10, that'll evenly divide. But of course, I have to multiply everything by 10. It's not enough, or I can't just multiply one term by 10, and I certainly can't multiply this by 2 and this by 5. I have to multiply everything by 10. So I do that now. 10 over 1 times 3 over 2 gives me 30 over 2x, which in turn becomes 15x. 10 over 1 times 2 over 5 turns into 20 over 5y, which becomes 4y. And then 10 times 5 is, of course, 50. And so that is now a system that I think you can deal with a little bit more easily. We won't go through this the whole rest of the way because I think you should be able to handle it at this point. But suffice it to say, when you have fractions or decimals in your equation, multiply by something. With its decimals, multiply by 10 or 100, if you want. If you can multiply and divide, if you can work with the equation with the fractions or with the decimals, if you don't need to change it, then don't. Leave it as it is. But that's the strategy of how you can deal with questions like that. Okay, so that is questions like number 1. Number 4 now. A little bit more complicated, so I'm actually going to go through this most of the way, but not exactly that question. I wanted you to use that question to be able to work on that question on your own, but we will have a new question to talk about. So the system that we're going to talk about, like question 4 now, is x minus 2 over 3 plus y minus 3 over 2 equals 1. And then x plus 6 over 4 minus y plus 1 over 3 equals 0. And so this is my new system that I want to talk about. And really, it kind of sets up the first part of it. Really works the same way as the one we just talked about. We have fractions. 3 and 2 are the denominators in the first equation. 4 and 3 are the denominators in the second equation. So I'm actually, as my first step, going to kind of treat this the same way as I did the previous problem. I'm going to multiply everything in the top equation by a constant that will make the denominators go away. In this case, it will be 6. because 6 will make each of those evenly cancel away. So I'll multiply that by 6, I'll multiply that by 6, and I'll multiply that by 6. Now I'll do this in green now. So 6 cancels with the 3 to become 2. So I get 2 times x minus 2. That's what that bit turns into. Then the 6 and the 2 cancel to 3, so that's plus 3 times y minus 3 equals 6. That's not nothing surprising or too remarkable there. Same idea for the second equation. Multiplying this term, and then that, although that's 0, so it doesn't really matter what I multiply it by. I'm going to multiply everything by, in this case, 12. 12, 12, and 12 again, though it doesn't really matter. So 12 and 4, they reduce to 3. 3 times x plus 6. 3 and 12, they cancel here to 4. So minus 4 times y plus 1 equals 0, of course. Now, there's a really important thing here that I've seen a lot of students kind of get mixed up about, and it's this negative sign, this minus sign. You really got to be careful with this minus sign, especially when you're dealing with fractions, with stuff in the numerators like this. You can't really ignore it. You have to keep in mind that you need to distribute the 4 with the negative sign, I should say. The negative sign with the 4. I'd say set it up like this as the first step. Cancel the denominator, but don't multiply the numerator right away. Give yourself a little bit of time to give, and especially a little bit of room to kind of manipulate this and set this all up. Once you get to this point, then you can start to distribute. So 2 times x minus 2 here gives me 2x minus 4 plus now 3y minus 9 equals 6. And then 3 times x plus 6 now is going to be 3x plus 18. So 3x plus 18. And then minus 4, now this is the important part because it's a negative 4. Negative 4y, and then negative 4. 1 times negative 4 is negative 4. Don't lose that negative sign. This needs to be minus 4y minus 4 equals 0. Now we can do combined like terms here. The minus 4 and the minus 9 give you negative, 13. So then negative 13 we can move over. This essentially turns into 2x plus 3y minus 13 equals 6, which then gives me 2x plus 3y equals, 13 plus 6 is 19. And so this is my one equation there. And then same thing down here, 3x minus 4y plus 18 minus 4 turns into plus 14 equals 0. So then this gives me 3x minus 4y equals negative 14. So I've taken my original equation, my original system, with all of these fractions and all kinds of weird stuff in the numerator, and I've converted it into 2x plus 3y equals 19, and 3x minus 4y equals negative 14. And this is a much easier system to deal with, I think. Again, we'll stop here. I trust that at this point you can solve equations or systems like this. It was just getting to that point was the tricky part. So that's question 4. We'll cross that out now. If you've been fast forwarding, now would be the time to join us back up again for 5 and 6, where you'll notice there's three equations and also 3 letters. So it's a little bit of a different situation. If you continue with your mathematical studies, you'll find that in order to solve a system of equations, in order to solve for a collection of unknowns, you need as many equations as you have unknowns. So when you just have x and y, or a and b, or p and q, plus 2b minus c equals negative 24, we need three equations. A minus b equals negative 5, and c equals 5b. I should probably have those all the way over to the left, but anyway. So there's three equations. And you'll notice that not every equation has every variable in it. In fact, the only variable that all three of these have in common is the b. And in your cases, on the homework exercises you have, you know, there might be other issues, other places, other examples like that. So there's a couple of different strategies that we can use, but the one that I'll use here is to, at least in these two cases, I'm going to solve for b. I'm going to essentially use substitution and get everything in terms of the same variable. What I really want essentially is to replace A, B, and C, or at least two of the three of those, with expressions that have all the same letter in them. So I either want to replace B and C with something with A in them, so I have everything in terms of A. Or I want to replace A and C with expressions with B in them, so now only B is there and I can solve for B. Or I would do the same and get everything in terms of C, so that I can solve for C as the first step, and then use these two equations down here to find what B and A are, or whatever selection we have. So I have that A minus B is equal to negative 5, and that C is equal to 5B. So right away I could replace C with 5B. I could substitute 5B in for C. So I'll actually do that. Let's see, I know I'm going to have minus 5B equals negative 24 as kind of the tail end of my equation there. And the 2B, that's what I'm trying to get all of my terms in, all of my variables in terms of, so that's not going to change. We'll have that. And so now this thing in the middle here, this A minus B equals negative 5, well, if I just add B to both sides, if I solve for A essentially, but get A in terms of B, I get negative 5 plus B, or if you prefer, B minus 5. And what this means now is I have A in terms of B, I have A in terms of B, I have C in terms of B, and then B is B. So I can replace A and C with B's. This is a little bit weird sounding, but when you see it all written out, it hopefully makes a little bit more sense, because I've found that A is equal to B minus 5, so I substitute in the B minus 5 in for A. And I found that C is equal to 5B, so I've substituted in the 5B for that. And then the B there is always been there. That's the B that we started out with. And so now we have an equation that is in terms of B, and we can solve it. So we do 6B minus 30 plus 2B minus 5B equals negative 24. Combine like terms, 6 plus 2 is 8, minus 5 is 3. So that gives me 3B minus 30, there isn't anything for that 30 to combine with, equals negative 24. Now I'll add 30 to both sides. I get 3B equals 6, which tells me that B is equal to 2. B equals 2. That is my, I know what B is. And so now that I know what that A is equal to B minus 5, well, A is now equal to, we know, 2 minus 5, because B is equal to 2. So A is equal to negative 3. And C is equal to 5B. Well, B is equal to 2, so C is equal to 5 times 2. So C is equal to 10. So my solution, then, is A equals negative 3, B equals 2, and C equals 10. That would be my solution. So when you have more than one unknown, you need, well, if you have more than 2 unknowns, you need more than 2 equations. 3 unknowns, you need 3 equations. 4 unknowns, you need at least 4 equations. So use substitution for these. That's the big, the moral of this story, if you will. Use substitution here. get everything in terms of one variable, get all of your other variables in terms of b, or in terms of whatever other variable. There's some hints on your paper, I think, for what you can use. And then substitute them into the equation that you started out with, solve that, and then use that value to find the other two that you were missing. So that is question 5. Question 5 and 6, really. And also question 10. I don't know if you've looked at the back yet, at the word problems back there. I'll tell you right now, question 10 kind of ends up working out pretty much the same way as this. And the last thing here, question number 7. I'm not going to do question number 7, but I'll just give you a little bit of advice. Because you have A's and B's and X's and Y's in that particular equation. But you're given a solution, the solution 15, negative 12. And remember, the solution 15, negative 12, that's what X and Y are supposed to represent. X is 15, Y is negative 12. So what's important to note then is that in question 7, your unknowns are actually the coefficients, A and B. You know what X and Y are. X is 15 and Y is negative 12. That's the point. Literally, that's the point that you're given, the ordered pair that you're given. So you can plug in those two numbers in for X and Y into the two different equations that you're given, and then manipulate those and solve for A and B. And you'll want to write out the final system of equations that you get. Rewrite the system of equations with whatever you find A and B to be. So that's question 7. If any of this doesn't still quite make sense to you, you know where you should be going. You should go to the homework help room during your lunch period, or go and see your teacher. Obviously, we are more than happy to help you out with any of these things. If you have trouble with the word problems, check out some of the other videos here posted on this page, and you should be able to work them out okay.